Greetings and welcome. This is Dr. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we are going to learn about the problems in centroid, center of gravity and moment of inertia. The tutorial question bank, which was provided along with the course Engineering Mechanics, we are going to see the module 3 of the syllabus, in which we are going to learn about the solutions for the important problems in the tutorial question bank from centroid, center of gravity and moment of inertia. Let us go to the first problem. The first problem given is, locate the centroid of the dam cross section shown in figure with respect to its base and vertical face. So before going to the problem, let us first recollect what are the basics that we need to understand about the centroid and center of gravity of any object. The centroid, which is defined as the point at which the total area of the surface is concentrated, the point is termed as the centroid. Whereas coming to the center of gravity, we are going to get the information regarding the mass of the object, or total volume is going to be concentrated at a single point. Then that point is called as the center of gravity. And understand this point, that the centroid and center of gravity are the points. That means we need some reference, whether it may be a datum of line or point, to represent the centroid or center of gravity. In the problems which we are going to solve, we are going to consider the reference datum as the axis, x-axis and y-axis. So from the x-axis and y-axis, which are going to be considered as the reference, the distance of that particular centroid or center of gravity will be gathered. So the distance of this centroid from the reference x-axis or reference y-axis will be treated as the coordinates of the centroid. Then that gives the solution. So we will be identifying the centroid in the form of x bar and y bar. So this point which we are going to identify will become our centroid. And the formula to identify this centroid will be for each individual coordinate, that is for x coordinate of the centroid, we are going to take the formula as sigma ax by sigma a, wherein a is the area of that particular part or the object. The surface which is given in the problem, we will be concentrating that area, total area of that surface, and that area will be considered, and x is the distance of this point, that is the centroid, from the reference y-axis. So x would be the distance from the y-axis and y would be the distance from the x-axis. So as discussed, similarly the coordinate of y for the centroid is given as sigma ay by sigma a. So why we are giving this sigma symbol here? Why we are applying the summation symbol here? Because if at all any complex or complicated surface is given, like 2 or 3 or more than one surface are given as a single component, more than one surfaces are combined and given as a single component, then we will be dividing this complicated surface or complicated area into known parts, regular shaped objects, whether it may be a triangle, whether it may be a rectangle, whether it may be a square. In this way, we are going to divide the given complex component into number of known regular shapes. So that's the reason we will be collecting the information about each and every individual part, and we will be summate them. So A1, A2 and A3 so on. Those will be the areas of parts 1, 2, 3 and so on. And coming to X, this is also the distance of that centroid of that particular part. The X coordinate distance from the reference datum for that particular point. So in this way we are going to solve the problem. So now after learning the basics, let us first solve the given problem. The problem given is, locate the centroid of the dam cross section shown in figure with respect to its base and vertical face. So here the data given, the base is 6 meters of length and the height of the dam is 10 meters of the length and the top width is given as 1.5 meters and the height of this part is given as 3 meters and the distance from this point to this point is given as 2 meters and this height is 1 meter in length. So this is what given in the problem. So from the given figure, what we will do as the first and foremost step, what we need to do is we will represent the reference axis. So we will be mentioning the x-axis and y-axis for the given complex shape, so that whatever centroid that we are going to identify, it would be from the distance of this reference axis. So as per the given problem, as per the given figure, it would be convenient to take the horizontal axis, which is x-axis, from the base of the surface, and the left portion, left side of the given structure, we can take the y-axis. So what we will do, we will consider the axis which is passing from the base in this fashion as x-axis, and whatever axis that is passing through the left side of this structure, let us take it as the y-axis. So whatever centroid that we are going to identify, that would be the distance of the centroid or point from this x and y axis. So as the first step, we have represented the reference axis. Now what we will do, the given surface is not a regular surface. That means we need to identify, or we need to divide the given surface into known regular surfaces or known regular areas. Here in this problem or in this figure which you can see, we can divide this figure into 3 parts by dividing this here. As one part and this as other part. So in this way, we have obtained the 3 parts, which are part 1, which is the regular rectangle, and part 2, which is the regular rectangle, and part 3, which is the regular triangle. So in this way, the given surface has been divided into 3 known areas. Now it would be easy to identify the centroids as per given figure. So for these 3 parts, what we will do, we will identify the centroids of these 3 parts individually first, and then we will use the formula to identify the overall centroid of this given surface. So as per this thing, first let us understand the first part. Let us take the part 1, which is of the shape rectangle, having the dimensions This is 6 meters. Overall length is 6 meters. So this 1.5 meters will be deducted from that 6 meters. So we will get the length of 4.5 meters. And the height is given as 1 meter. The height is given as 1 meter. So in this way, we have taken the information regarding the part 1. Now let us identify the x coordinate, y coordinate and area of this part 1. What is this x coordinate x1? x1 is the distance of the centroid from the reference axis. So where is that reference axis passing from? Reference axis passing from base here. So as you can see, the box or part 1 which is selected here, the axis is passing through that base. So the axis, reference axis is along the base of that part 1. So if we consider the centroid of this particular object, particular rectangle, we can identify that the centroid of this particular rectangle would be the intersection of the two diagonals. Hence, that distance from the bottom would be half of this thing, isn't it? Half of the side. So that means 0.5 meters would be, or we can say this is 1 meter. So half of the distance would be this distance, that would be 0.5 meters. That is the 0.5 meter distance from the base. Now coming to the centroid of this particular object from the left hand side or y-axis which we are considering. So as this is x1 is 0.5, that we can write here, which is 0.5 meters. So this 0.5 meters would be the distance of the centroid from the y-axis. Distance of the centroid from the x-axis. So the distance of the centroid of this particular part 1 from the x-axis would be the value of y1. So the y1 value would be 0.5 meters. Coming to x1. What is the x1? The x1 is the distance of this particular object or distance of this particular centroid from the y-axis. So where is the y-axis lying here? The y-axis lying at 1.5 meters distant. 1.5 meters distant from the part or area which we have selected here. Actually, the centroid of this particular rectangle would be at 4.5. Whatever length we have selected, that 4.5 length. So the centroid will be lying at a distance of 4.5 by 2. Also, whatever centroid, that is the centroid of that particular point 1 or part 1 will be from the y-axis. So that distance is 1.5 meter axis. So we can take that y-axis distance as 1.5 meters plus 4.5 by 2. Hence, the distance of the centroid from the y-axis, which is x1, can be taken as 1.5 meters plus 4.5 by 2. Hence, that can be written as 1.5 plus 2.25. That gives the value as 3.75 meters. So this 3.75 meters is the distance of the centroid of part 1, centroid of first rectangle from the y-axis which we have selected for here, the total figure, y-axis which we have selected for the total figure. So we need to highly concentrating while solving this type of problems. Why? Because the involvement of the centroid should be considered from the reference axis. So blindly we cannot place that the centroid's distance is 4.5 by 2 from the y-axis. Why? Because the y-axis is lying at a distance of 1.5 meters as shown here, 1.5 meters away from the selected part. Now coming to the area of that first part, we have got the values as 4.5 length into breadth as 1. So that would be 4.5 meters square. So this is regarding the part 1. Now let us go to part 2. For this part 2, which we have selected here, first let us draw the figure. The part 2 is the second regular rectangle, which is having a distance of 10 meters, the height, or we can say the breadth as 10 meters and length as 1.5 meters. Now, both the axes are passing from the base and the left portion of the selected second part, that is rectangle. So what we can consider, the centroid of this particular rectangle can be taken as the intersection of the diagonals. Now, for identifying the x2, x3, x2, y2 and a2, what we can take, x2 is the distance of the centroid of this particular rectangle from the reference y-axis. So as the y-axis is passing through the left portion of this rectangle, directly we can take the distance here. So how much would that distance be? That would be 1.5 by 2. So that gives 0.75 meters. Similarly, y2 is the distance of the centroid of this particular rectangle from the x-axis, which is passing from the base of the rectangle. Hence, this distance would be directly giving the value of y bar or y, that is y coordinate. That means the distance of the centroid of this particular rectangle from the base axis, that is x-axis. Hence, that would be 5, as the total length is 10 meters. Half of that would be 5 meters. So y2 would be 5. Then coming to area, length into breadth, we can take 1.5 into 10. So that will give 15 meters square. In this way, we have identified the x1, x2, y1, y2 and a1, a2 of the two parts, that is regular rectangles. Now let us go to the third portion, that is third part. Let us take the figure here. This would be our third part, which is the triangle. This length or height is 1 and this width is 1.5. This total is given as 10. This one is 3 and the total base is 6. So this is the value given. From this, we need to identify the centroid of this triangle. We already know that the centroid of this particular triangle, any triangle, is taken as the coordinates base by 3 and height by 3. That is, base of the triangle by 3 and height of the triangle by 3. What is the distance of this base and h we can represent? Here, we have already taken the values. See, this distance is 4.5, which is given, isn't it? Now, this length would be 4.5 minus 2. The total 4.5 length minus 2. This one will give the length of this portion, the base of the triangle. Similarly, the height of the triangle H can be identified as the total. We can take the total length from here, that is 10. So we can obtain this as 10 minus the height of this portion as 1 and 3. So total it is 4. So we can subtract that 4 from the 10. Then we can obtain the value as 6. So this would be 2.5. So base of the triangle can be obtained as 2.5 and height of the triangle can be obtained as 6. Right? So in this way we can give the values. Now for part 3, which we are going to identify the centroid, we can take it as x3, y3 and a3. Now let us identify the x3, y3 and a3. This is 3 given, this is 2 given, right? Now in this way we can find the x3 and y3. Now what is x3 here? x3 is the distance of the centroid of this triangle from the y-axis. Okay, so y-axis is lying here, isn't it? Y-axis is lying here. So this distance, that means plus this distance, will be taken as the distance of the centroid from the y-axis. This distance is given as 1.5 plus this distance is just now we have calculated, which is b by 3. So we can take it as b by 3. So x3 can be written as b by 3 plus 1.5. So that can be taken as b value is 2.5 by 3 plus 1.5. So that gives the value as 0.84 plus 1.5. So that means the value is 2.34 meters. 2.34 meters. Similarly, y3. y3 is the distance of the centroid of part 3, which is the triangle, from the x-axis. X-axis is lying here. So the distance can be identified here in this fashion. This height is already taken as 1 and this height to be represented, that is taken as h by 3. So the value is h by 3 plus 1. What is the h value that we have obtained? The h value which we have obtained is 6 by 3 plus 1. So that means 2 plus 1, that gives the value as 3 meters. So this is the y coordinate of the centroid of this particular triangle from the x-axis. Now coming to A3, that is area of the triangle, that can be taken as half base into height. So the value would be half into the base value is taken as 2.5 into height is 6. So from this we can write it as 7.5 meters square. So in this way we have obtained each individual centroids of all the 3 parts with respect to the reference x and y axis. So now we can utilize all the values of x1, x2, x3, y1, y2, y3, a1, a2, a3 and substitute these values in the formula of centroid and we can obtain the centroid value, coordinates that is. So first let us write down the formula for the centroid, that is x bar is equal to sigma ax by sigma a. So this sigma Ax and sigma A can be taken as A1x1 plus A2x2 plus A3x3 by A1 plus A2 plus A3. We have taken only 1, 2, 3 because there are only 3 parts in the given figure. So the given figure has been divided into 3 parts. Hence we have taken 1, 2, 3. Now let us substitute the values of A1, x1, A2, x2, A3, x3 and A1, A2, A3 in the formula so that we will get the value of x bar. So let us substitute the values. The values can be substituted as shown here. That is 4.5 into 3.75 plus 15 into 0.75 plus 7.5 into 2.34 divided by 4.5 plus 15 plus 7.5. So when you solve this equation, you will get the value of x bar as 45.675 by 27. That is equal to 1.69 meters. This is the x coordinate of the centroid of total complex surface. Now similarly, we can substitute the values of x1, y1, y2, y3 and a1, a2, a3 to identify the y coordinate of the centroid. The formula can be written as ay sigma ay by sigma a. That means a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. So here we can substitute the values of these items and we can get the answer. So let us substitute that. 4.5 into 0.5 plus 15 into 5 plus 7.5 into 3 by 4.5 plus 15 plus 7.5. When you solve this, you will get the value as 99.75 by 27. That will give the value as 3.69 meters. So this is the y coordinate of the centroid of the total surface. Now as the answer you can write the x coordinate and y coordinate of the centroid of the given lamina is 1.69 meters, comma 3.69 meters. So this is the solution of the given problem. In this way, in a sequential manner, we can take down the small details of from the given figure and then we can identify the centroid. Now let us go to the next problem. So here there is a rectangular lamina given and also whatever color shaded area is the material available and non-color shaded area, which is this 30 by 40 size, it is non-material. So it is non-material shape. Hence whatever color shaded area is available here, it is material area and this non-color area is the non-material area. So the problem given is in a rectangular plate of 100 by 120 mm and of negligible thickness, a rectangular cut of dimensions 30 by 40 mm is made as shown in figure. Now identify the position of centroid of the remaining part of the plate. So for identifying the centroid of this given figure, what we can do, as the first step, we can give the axis, and as the second step, there are two rectangles which we can see here. So we can divide this given lamina into two shapes, which is two rectangles. And as the third step, after identifying the x coordinates and y coordinates and areas of individual rectangles, we need to apply the formula of the centroid. In this particular figure, this area needs to be subtracted from the total area. This area's details should be subtracted from the total area. So what we need to do, in the formula, that is x bar is equal to sigma ax by sigma a, we need to subtract a1 x1 minus a2 x2 by a1 minus a2. Similarly, y bar is equal to sigma ay by a, sigma a. So that means a1 y1 minus a2 y2 by a1 minus a2. So here, as you can see, the second part's value or second part's details will be subtracted from the first part details, so that whatever non-material condition or non-material shape is available here, it will be removed. And after removal of that particular shape, then the centroid of that particular object, the total lambda, can be identified. So that is the difference. In the previous case, previous problem, what we have seen, that is the complete material oriented area and all the individual shapes have been added. But here, the non-material area that is available should be subtracted from the material area. So that is the basic step. Now, after understanding the procedure, let us go to the problem and solve this given problem. As per the procedure, the first step of this solving the problem would be representation of the axis. So where can we represent the axis? It would be convenient for us if we take the axis at the bottom of the object, that is the base of the rectangle, as x-axis, which is horizontal axis, and to the adjacent of the left portion of this object as the y-axis. That means this y-axis is passing through the left portion of the rectangle. So these are the two reference axes which we are considering. Now we can solve the problem. As the previous case, we will first divide this object into given regular parts. So this object can be divided as one main rectangle as part 1 and one sub-rectangle as part 2. So after identifying the centroids of these part 1 and part 2, we will be subtracting the centroids details of part 2 from part 1, so that we will get the solution. Right? So now let us start the problem. Let us first take the part 1. So the part 1 size which is taken or which is given is 120 mm of height or breadth and 100 mm of length. So directly we can obtain the values of x1, y1 and a1. What is x1? x1 is the distance of the centroid of this particular part 1 from the y-axis. So the horizontal length or the length is given as 100 mm. Hence the centroid would be lying at middle, the intersection of the diagonals. Hence the distance would be 100 by 2, that is 50 mm. Now coming to y1. Y is the coordinate, that means the distance of the centroid from the x-axis. The total height or the breadth is given as 120 and the centroid will be lying at half of this 120. Hence, we can type it as 120 by 2. Half of this 120 from the x-axis. So that would be 60 mm. Now coming to A1. Area of this rectangle, that is length into breadth. So we can take it as 100 into 120 mm. So that can be taken as 12,000 millimeters square. This is regarding the part 1's details. Now coming to part 2. The details of part 2 can be taken like this. This part 2 is lying as shown here. So, the horizontal distance of the centroid and vertical distance of the centroid from the reference axis, first let us calculate. So, it is given, let us say, the centroid of this particular second part of rectangle would be lying at the intersection of the diagonals, let us say here. That means from the vertical it would be 15 and from the horizontal, that means this distance, it would be 20. So this is related to that particular second part of the rectangle. Now when we consider this centroid from the reference axis, the addition of the distance from the reference axis should be done here. So from the y-axis we can take, what is this distance? This is 50 plus this is 10. So the total becomes 50 plus 10 plus 50. So that would be 75 mm. Now coming to vertical, from the x-axis we can take this length. This length would be, this total is 40. We know that this total is 40. Hence, from this 60, if we subtract 40, that means 20 would be this length. So what would be the overall distance of this thing? 20 plus 20, that would be 40. So this is how we need to identify the distance of the centroid from the reference axis. You should repeatedly practice for non-confusion solution of this type of incidents or problems. So in this way, we can identify the distances of the centroid from the reference axis. So now let us go to part 2 and take x2, y2 and a2. So x2 would be distance of the centroid of part 2 from the vertical y axis. So what would be that distance? 50 plus 10 plus 50. So that gives 75 mm. Now coming to y2, which is the distance of the centroid of this part 2 rectangle from the x-axis. So that would be 20 plus 20. That would be 40 mm. Now coming to area of that particular rectangle, length into breadth. So that value would be mm square, 1200 mm square. So with this, we have identified the values of x1, y1, x2, y2 and a1, a2. Now we can substitute these values in the formula for identifying the solution. Now let us identify the x bar, and the formula given is sigma ax by sigma a. So that would be a1 x1 is the information about first rectangle minus a2 x2 we need to subtract from the first part. Then A1 minus A2. When you write the information or substitute the values, we will obtain it as 12,000 into 50 minus 1200 into 75 by 12,000 minus 1200. So the value would be 510000 by 10800. So X bar is 47.22 mm. Similarly, coming to Y bar, that would be sigma AY by sigma A. So here also we can take it as A1 Y1 minus A2 Y2 by A1 minus A2. So when you substitute the values of Y1 Y2 and A1 A2, we can obtain it as 12,000 into 60 minus 1200 into 40 by 12,000 minus 1200. So the value is 672,000 by 10800. So with this, we will get the Y bar value as 62.22 mm. This is Y bar. So in this way, we will get the solution of the centroid. So ultimately, at the end, you can write the solution as the centroid of the given complex lamina is X bar comma Y bar, that is equal to 47.22 mm comma 62.22 mm. So this would be the solution of the given problem. Now let us go to the next problem. So the problem given is determine the coordinates of centroid of the shaded area shown in figure. So this is the complex area that is being given here. All the units are in centimeters and it is given in the form of 30 centimeters for all the sides. So if you observe here carefully, we can see three different shapes. The first shape would, one of the shape would be triangle, another shape would be the quadrant of the circle, and another shape would be this rectangle. So this would be other shape, that is complete rectangle. So as per the given figure, we can identify the centroid of this figure by the simple logic which we have utilized in the previous problem. That is, we are going to subtract this quadrant's centroid details from this total shape. From this total shape. If you observe that shape, you can understand that the shape is lying here in this fashion. This is the complete shape given and this portion is not available. This portion is not available. So this is non-material condition. So from the total shape, we can subtract this quadrant, circular quadrant details, and we can get the solution for the given problem. Now let us go into the problem. As this is the same case as the previous case problem, we start the problem and do for the solution. Now, the very first step, as we have discussed, would be the taking reference axis. So the axes are given as it is in the figure, that is, this would be the x-axis and this would be the y-axis. And the shapes which we are going to divide, as we have discussed, we are going to divide the shapes as the rectangle as the first part, the triangle as the second part, and this quadrant as the third part. So these are the three parts which we have in this given figure. So first let us understand the details about the part 1, which is rectangle. So if you consider the size of this rectangle, it would be, the radius given here is 30. Hence, this will also be 30. So the total length of this rectangle would be 60 centimeters. Hence, we can directly take that value of length as 60 centimeters. So first, let us draw this first part of the rectangle as 60 and 30. Now we can identify the values, as the x-axis and y-axis are adjacent to both the sides of this rectangle. We can take it as x1 is equal to, x1 is nothing but the distance of the centroid of this part 1 from the y-axis. Hence that would be 60 by 2, and that gives 30 centimeters. Now coming to y1. y1 is the distance of the centroid of this particular rectangle from the x-axis. So that would be 30 by 2. Hence it would be 15 centimeters. Now coming to the area. Area is length into breadth. Hence it can be 1800 centimeters square. So these are the details of this first part of the rectangle. Now let us go to the part 2. Here for part 2, let us say the centroid is lying here in this condition, and the distance will be considered in this fashion as b by 3 comma h by 3. The quadrant of the centroid can be taken as b by 3 comma h by 3, wherein this b by 3 and h by 3 will be considered from this adjacent side, or we can say from this axis and the base axis, like this. This centroid will be considered from this vertical thing and this horizontal thing. This would be b by 3 and h by 3 would be considered from distances as shown here. So we need to identify the centroid of this particular triangle from the reference axis. That means this total distance we need to identify for x bar or x, we can say, and this total distance from here to here would be for y1 or y2. Okay, so here there is a slight understanding which we need to see here. The centroid quadrant which we are taking, the coordinates of the centroid would be from the reference axis, and b by 3, h by 3 are the coordinates of this centroid from the axis which is shown here, this line and this line. Okay, so for identifying x2, let us say the x coordinate of the centroid of this particular triangle, what we can take, we will be taking this 30. We know that this is from 30, and then this distance is also 30. So what we can do, from this 30 to overall distance, we will be subtracting this portion, which is b by 3. So that means this 30 plus this total 30 minus this b by 3 will give the distance of the centroid of that particular triangle from the reference y-axis. So in this way, we can take it as 30 plus 30 minus base is 30, isn't it? The base is 30, hence 30 by 3. So that would be 30 plus 30 minus 10. So that would be 30 plus 20. Hence the value is 50 centimeters. So x2 is the 50 centimeters. That is the distance of the centroid of that particular triangle from the vertical y-axis or from the y-axis. Now similarly, we can consider the same thing for y2, which is the distance of the centroid of this particular triangle from the x-axis. So that would be 30 plus this centroid would be h by 3. Hence, that would be 30 by 3. So that would be 30 plus 10. Hence, it is 40 centimeters. So 40 centimeters from the x-axis and 50 centimeters from the y-axis. Now, we can select this A2, which is half base into height. So that would be half into base is 30 centimeters into height is 30 centimeters. So that value we can obtain it as 450 centimeter square. In this way, we have obtained the details about the triangle or the second part of the figure as given. Now let us go to the third part, which is the quadrant of the circle. Quadrant of the circle, and the radius given is 30. Okay, so the centroid will be lying somewhere here. Let us take the centroid lying here. Now for part 3. We need to understand here again that the remaining axes which are present here, that is y-axis and this x-axis, are like this. So this distance is also 30. Now coming to the quadrant, the centroid will be lying at a distance of 4r by 3 pi, comma 4r by 3 pi as per the formula from this axis. As we have seen in the triangle, the same case here also we can observe here that the quadrants of the centroid of this particular coordinates of the centroid of this particular quadrant will be from this vertical and horizontal positions. So what we can do for identifying the x coordinate of this centroid, we have to consider the distance from here, this total distance. Hence that total distance would be this 30 and subtraction of this portion from the or else we can take subtraction of this portion from the total 30. So 30 minus, and this portion length would be 4r by 3 pi. 4r by 3 pi. So addition of this 30 plus 30 minus 4r by 3 pi would be the distance of x coordinate of the centroid from the y-axis. So we can write here as 30 plus 30 minus 4 into 30 by 3 pi. So solving this, we can get it as 30 plus 30 minus 12.73. So further simplification, you will be getting the value of x3 as 47.27 centimeters. Similarly, the value of y3. So y3 directly the distance is from axis which is passing through the base of the quadrant. So directly we can take it as 4r by 3 pi. Hence it would be 4 into 30 by 3 pi. When you simplify this, you will get the value as 12.73 centimeters. Now coming to area, A3. Area would be pi r square by 4, the quadrant's area. Hence we can substitute the value as pi into 30 square by 4, and the value is 706.86 centimeters square. So in this way, we have obtained the values of 3 parts, part 1, 2 and 3. Part 1 is the rectangle, part 2 is the triangle, and part 3 is the quadrant. So these 3 details will be substituted into the formula for identifying the centroid. So the centroid formula, we can take it as x bar is equal to sigma ax by sigma a. So that would be a1x1 plus a2x2. These two are material surfaces, and minus a3x3, which is the non-material area, and a1 plus a2 minus a3. So substituting the values here, we can get 1800 into 30 plus 450 into 40 minus 706.86 into 47.27 by 1800 plus 450 minus 706.86. So when you solve this, you will get the value as 38586.73 by 1543.14. So that is 25 centimeters. This is the x coordinate of the centroid of the given complex lamina. Now coming to the y coordinate, sigma ay by sigma a. So that would be a1y1 plus a2y2 minus a3y3 by a1 plus a2 minus a3. So similar fashion, we will be substituting the values. The values are 1800 into 15 plus 450 into 40 plus 706.86 into 12.73 by 1800 plus 450 minus 706.86. So when you simplify this, you will get the value as 36001.68 by 1543.14. So the value is 23.3 centimeters. So ultimately, you can give the result as the centroid of the given complex figure is x bar comma y bar is equal to 25 centimeters comma 23.3 centimeters. So this is your solution to the given problem. So in this way, we can solve the centroids and center of gravities of the given complex shapes. Now let us go to the moment of inertia problems, wherein we will identify the moment of inertia of the given complex lamina. So first let us understand what are the basics that we need to follow for solving this kind of moment of inertia problems. So the first stage would be, as we have done in the centroid itself, we will be identifying the regular shapes from the given complex lamina, and then we will be identifying the moment of inertia of these regular parts, these divided regular shapes with respect to the centroidal axis. And once the centroidal axis moment of inertia are identified for individual parts, then we can sum all these moment of inertia for obtaining the solution. So now you need to keep it in mind that whenever we are going to solve a moment of inertia problem, the very first thing which you need to get into your mind is with respect to which axis. The identification of moment of inertia is with respect to which axis. So here in the question it is given as find the moment of inertia of section shown in figure about the centroidal axis parallel to the base. So the problem given here is a C section and the sizes are given as per the given data 20 mm or 10 mm, 90 mm, 10 mm, 120 mm and 120 mm. In this way, the dimensions of the C section are given. Now, we can easily identify the centroid of this C section. We can identify the centroid of this C section, and the axis which passes through this centroid, we need to identify the moment of inertia. So here we need to understand another point that it is been asked to identify the moment of inertia with respect to the centroidal axis parallel to the base. So only one axis it has been asked. So we can see the parallel to the base axis would be like an x-axis that is passing through the centroid. Let us say the centroid we have obtained somewhere here, and the axis that passes through this centroid, we need to identify the moment of inertia. So there is no need to identify the x coordinate here for this particular centroid. Why? Because we don't need the distance of this centroid from the vertical axis. We only need the distance of this centroid from the horizontal base axis. So if we identify the y bar alone, it is sufficient to solve this moment of inertia problem. So with this basics, let us start the problem. So as the first case, as we have discussed, we need to first identify the moment of inertia or the centroid of this particular C section. That too, we need to identify the centroid coordinate from the x-axis. Hence, if we find the y bar alone, it is sufficient. So first let us find the y bar, that is the centroid of this particular C section. The procedure is same which we have done. That is, first we need to identify the axis. Here we are taking the axis as the base, the x-axis as the base of the C section. And we are taking the values of this centroids of each individual parts. So the parts which are being divided here is like this. Let us divide this given C section in this fashion. That is, this is part 1, this is part 2, and this is part 3. Okay. So in this way, we have divided the given C section into 3 parts. Now, we will identify the centroid's distance of each individual parts from the x-axis alone. That means y coordinate alone we are going to consider. So for identifying this, we need the values of y1, y2 and y3. Also, we need the values of a1, a2 and a3. Now, y1 is the distance of the centroid of this part 1 from the reference x-axis. So this height is given as, total height is given as 20. Hence, this would be 10. Hence, y1 would be 10 mm. Let us take the units in mm here. So y1 would be 10 mm. Then coming to y2. y2 is the distance of the centroid of this part 2 from the x-axis. So as this x-axis is passing through the base of this part 2, again half the distance of the total height can be taken. So that would be 60 mm. Now coming to y3. So y3 is the centroid's distance from the axis, reference axis here. So total length we have taken as 120 minus this top 5. If we subtract half of this 10 from this total 120, we can get the y coordinate value of this centroid. So that would be 115 mm. So in this way, we have obtained the y coordinates of this, all the 3 parts that are being divided. Now coming to the areas. Areas would be A1 is equal to 120 into 20. The division which we have made, that is, the division has been made here till here. So this length would be 110. 110 into 20, that is length into breadth. And A2 would be 120 into 10. And then A3 would be 80 into 10. So this is mm squares. So in this way, we have identified the details which can be kept in this sigma ay by sigma a. So let us substitute the values. Y bar is equal to 110 into 20 into 10 plus 120 into 10 into 60 plus 80 into 10 into 115 by 2200 plus 1200 plus 800. So when you solve this, you will get the value of y bar as 44.28 mm. So in this way, we have obtained the value of y coordinate of the centroid. That means from the base, the centroid is lying at a distance of 44.28 mm. This is the first stage of the problem, where we have identified the centroid of the given C-section. Now, as the next stage, we will start to identify the moment of inertia. So before that moment of inertia process is started, let us first identify the terms which are needed for substituting in the formula. The given figure here is in this way. C-section, given C-section, and we have obtained the centroid. We have obtained the centroid at a distance of 44.22 mm from the x-axis. Okay. Now what we need, as per the formula of the moment of inertia, that is moment of inertia I is equal to Ig plus AH square. We need the values of H1, H2, H3, A1, A2, A3, and the values of B1, B2, B3, and D1, D2, and D3. Now all these values can be identified from the figure, and then we will start the problem. Now coming to H values. The H here in the formula is the distance between the reference axis and the centroidal axis, right? So the reference axis would be this axis which we are going to get the value from, and the centroidal axis would be the centroidal axis of the parts which we have divided, right? Part 1, part 2 and part 3. That means if for the part 1, let us say the centroidal axis of that part 1 would be like this. That is the axis that is passing through the centroid of this part 1. This distance would be H1. That distance would be H1. And that H1 distance can be obtained as subtracting this 44.22 and this distance, that is given as 20. That means this would be 10. Okay. So that distance would be 44.22 minus 10. And that will get as 34.22 mm. So this is 44.28 which we have obtained. So that would be 34.28 mm. And now H2. H2 is the distance of the centroid of the second part. Let us say the centroid is traveling here, passing here. The total distance is taken as 120, isn't it? And from this 120, if we take this distance, from this 120, if we take this distance, we will be obtaining the distance of the centroidal axis and the reference axis. So this distance can be obtained in the form that this total 60 minus this 44.28. So that would be 60 minus 44.28. So that will be obtained as 15.72 millimeters. Now coming to the third part, that is the centroid of that third part is lying here. The height is taken as 10 here, total height, and this distance would be 5. This is 5 and this is 5. So this distance, the total distance can be obtained from this total of 115 and minus this distance. So we can get the value as 115 minus 44.28. So the value is 70.72 mm. Right? So from this total 115, that is the centroid's part 3 centroid that is lying there, minus if we remove this 44.28 distance from this total length, if we remove this 44.28 length, we will be obtaining this distance. In this way, we have obtained the values of H1, H2 and H3. Now coming to the areas of these three parts, we have already calculated that the areas are A1 is 2200 millimeter square, A2 is 1200 millimeter square, and A3 is 800 millimeter square. Now coming to B1, B2, B3 and D1, D2, D3. So this BDQ by the moment of inertia of a rectangular lamina. Moment of inertia of rectangular lamina is given as BDQ by 12. Hence we will be identifying the values of B and D here. So for the first part, the B1 value would be 110, that is base, and D1 would be 20. Then B2 would be 10 for the second part, and D2 would be 120. And B3 would be 80 for the third part, and D3 would be 10. So in this way, we have obtained all the values of the required formula. Now let us go to the substitution of these values and identify the moment of inertia. So for the first part, the moment of inertia is taken as Igx1 plus A1 H1 square. So if we further go to the formula, it would be moment of inertia of this part 1, the centroidal axis part 1 is B1 D1 cube BD cube by 12 plus A1 into H1 square. So when we substitute the values, it would be 110 into 20 cube by 12 plus 2200 into 24.28 square. Now further simplification, you will get the value as 1370273.81 millimeter to the power of 4. So moment of inertia unit will be length to the power of 4. Now similarly, Ix2, that means moment of inertia of part 2 with respect to the total sections centroidal axis. Hence that would be Ix2 is equal to Igx2 plus A2 H2 square. All these values we have obtained in the previous slide, right? So B2 D2 cube by 12 plus A2 H2 square. When you substitute the values, you will get 10 into 120 cube by 12 plus 1200 into 15.72 square. So when you solve this, you will get the value as 173654.2.08 mm to the power of 4. Now coming to Ix3, the third part's moment of inertia with respect to the centroidal axis of the total lamina, Igx3 plus A3 H3 square. So that would be B3 D3 cube by 12 plus A3 H3 square. So the value are 80 into 10 cube by 12 plus 800 into 70.72 square. When you substitute the values or solve the equation, you will get 4007721.39 mm power 4. So in this way, we have obtained the moment of inertia of all the individual parts with respect to the centroidal axis of the total lamina. Now what we will do? For obtaining the moment of inertia of the total lamina Ixx, we will be adding all the moment of inertias Ix1 plus Ix2 plus Ix3. When you add all these values, you will be getting the value of moment of inertia as 7114537.28 mm power 4. So this is the moment of inertia of the total lamina with respect to the centroidal axis which is parallel to the base. In this way, you can solve the moment of inertia problem for a complex lamina. Now let us go to the next similar problem wherein we are going to identify the moment of inertia for a I section. The problem given is find the moment of inertia of section shown in figure about the centroidal axis perpendicular to the web. So this is the web of this I section, and the perpendicular to the web axis would be this one, which is the horizontal axis, and this axis is passing through the centroid of this total lamina. The axis will be passing through the centroid of this total lamina. So for that axis, with respect to that axis, we need to identify the moment of inertia of this I section. So let us start the problem. If we are going to do the problem to identify the moment of inertia, first we need to identify the centroid. As this given I section is symmetric about the y-axis, that is central axis, y-axis, the centroid will be lying on that y-axis, and we can say the y-coordinate of this particular I section, y-coordinate of this particular centroid of the I section will be passing through the centroid of this particular I section. Hence, what we need to do, we will be identifying the centroid first. So, as per the procedure for identifying the centroid, what we will do is, we will divide the given lamina into 3 parts, 1, 2 and 3. So, as shown here, we are going to divide the lamina into 3 parts, and the identification of the centroid for this total lamina is been done previously. Hence, the value of y1, value of y2 and value of y3, which are the y coordinates of the centroids of individual parts are being identified, and also the areas A1, A2, A3 will be taken. Now, after the identification of the y1, y2, y3 coordinates, we can identify the h1, h2 and h3 of the problem or the lamina, as we have already identified the centroid for this particular complete composite lamina. Now, for identifying the centroid, the given section is symmetrical about y-y axis, and its centroid will be on y-y axis. Then divide the given section into 3 rectangles that we have done. After that, the areas A1, A2 and A3 and the centroids y1, y2, y3 are being identified in this fashion, and then the y coordinate of the centroid of the total lamina is being taken, which is A1 y1 plus A2 y2 plus A3 y3 by A1 plus A2 plus A3. So when you substitute the values, 10 into 1 plus 20 into 7 plus 20 into 13 by 10 plus 20 plus 20. So when you solve this, you will get the value of y coordinate as 8.2 centimeters. So the moment of inertia of rectangle is Ix1 is equal to Ig1 plus A1H1 square is equal to B1 D1 cube by 12 plus A1H1 square, that is equal to 5 into 2 cube by 12 plus 10 into 7.2 square. When you solve this, you will be getting the value as 521.73 centimeter power 4. Now the moment of inertia of the rectangle 2 is Ix2 is equal to Ig2 plus A2H2 square, that is equal to B2 D2 cube by 12 plus 20 into 12 square, that is equal to 2 into 10 cube by 12 plus 20 into 1.2 square, that is equal to 195.47 centimeter power 4. And the moment of inertia of the rectangle 3 is B3 D3 cube by 12 plus A3H3 square, that is equal to 10 into 2 cube by 12 plus 20 into 4.8 square, that is equal to 467.47 centimeter power 4. So now, after identifying the moment of inertia of all the different parts or divided parts, now we can identify the moment of inertia of the total lamina with respect to centroidal axis xx as Ix is equal to Ix1 plus Ix2 plus Ix3. That would be 521.73 plus 195.47 plus 467.47. So ultimate answer would be 1184.67 centimeter power 4. So in this way, we can identify the moment of inertia of the complex laminas. The procedure which we have discussed, sequentially we need to follow, and gradual implementation of the formulae and substituting the identified values will yield the right result. We should not go further in a fast manner, as the confusion may arise while substituting the values and identifying the distances between the centroidal axis and reference axis. All these things we need to keep in mind and solve the problems. So with this, we have completed this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.